Pitless drilling technology by Smartline Energy Solutions. Why should we adopt and use pitless drilling technology? I'm going to start off by covering the short agenda here, which will start with a video on why adopt pitless drilling. We'll cover the history of pitless and Smartline Energy Solutions. What is pitless drilling? How does it work? Why should we use it? And we'll wrap up with some case studies. This is the video.
For years, the drilling process has left a lot to be desired. It's time to drill smart. BOE Energy Systems develops clean energy solids control and dewatering technology for well site drilling operations in the US, Canada, and around the world. Improve drilling performance, but not at the expense of the environment. Unparalleled safety and operational efficiency with internal controls and innovative off-site monitoring capability. Precise control of fluid density during drilling, saving significant time and cost. With its unmatched flexibility and throughput capacity, it is the most sophisticated fluid management system in the world. BOE Energy Systems. Go green. Drill smart. Get BOE.
We'll cover the history of pitless and the birth of Smartline Energy Systems. 1995 saw the origination of the pitless drilling concept in Canada with the introduction of modular style equipment. At that time, Canada utilization rate of around 10%, USA GCC at 0. 2002 to 2005, we saw the introduction of the first integrated pitless drilling system in Canada and the expansion of pitless technology to the US market. Canada by now is around 70% utilization on pitless, with the USA just beginning at 10%, GCC 0. 2012, we saw the development and introduction of the second generation pitless drilling technology, and the Canada now at 100% utilization, USA at around 90%, GCC 0. 2015-17, we saw the introduction or the exportation of the second generation technology into Cuba and also here into Oman. The establishment of Smartline Energy Solutions in Oman to serve the GCC MENA region with pitless technology. Canada's utilization at 100%, USA at 95%. By 21-22, we'd completed 6 successful trials in Oman, and we're looking for expansion into other GCC countries. Canada's utilization 100%, USA 95%, and now GCC at around 1%. So what is pitless drilling technology? Well, as the current methodology is pits, it's old, it's harsh technology, and it's very bad for the environment. A few pictures there are the examples of what waste pits look like. You have no perimeter fencing in some cases. We've got pit liners in there that leave a 1,000-year legacy behind. Ongoing environmental and safety liabilities associated with these, with the nasty fluids remaining in the pits. So pitless drilling, as the name implies, is a proven technology that successfully eliminates the reliance on the use of water or waste pits in support of a drilling operation. Now here's a look at the kit that we'd be using. I'll talk about it more in the next slide. So with this patented pitless technology, the SmartSite pitless drilling system, numerous benefits to the environment, workplace safety, and drilling performance can be realized. So here, as I say, is the kit. There's a number of features here that are associated with it. I'm not going to go over all of them. I'm just going to highlight some of the main features. And here's the centrifuge platform. You can see its proximity and location to the drilling platform. We can have any combination of different sizes machines, 2 different combinations of, or 2 different centrifuges of different combinations and sizes, and they can give you throughput flow capacities of up to 1,500 gallons per minute or 6 cubic meters per minute, depending on your particular drilling operation. The cuttings collection bin, which is the primary collection cuttings bin, is going to position by the shakers. We're going to collect the shaker cuttings, and we're also going to collect any discharge from the centrifuges. And the third element of this system is the RCT. You see its location directly below the shaker slides. We will collect, in the top right picture, water-based processing in effect. Lids are closed. In the bottom right picture, lids are open, and we're now collecting the cuttings off the shaker for secondary processing. Typical site layout, to just give you a reference point, that red dot's your well center. And the essential equipment that we have, that make up the two main components, the SmartSite tank with the centrifuge package, polymer injection control system, and the primary cuttings collection bin, which is a combined load with the RCT. And in the GCC, we've added the workshop and part storage for the house critical spares. Depending on your drilling operation, you're going to need other auxiliary equipment, will be rig site and well site dependent. The first one of those is the flare tank. Because we're eliminating the waste pit, there will be a need to terminate that flare line somewhere. And the flare tank provides a very safe alternative to your current methods. Additionally, generators, we need 400 kilowatts, 480 volts of 60 hertz power dedicated for our system. In some cases, we're asked to provide 2 generators, so there's redundancy. Again, that's going to be operator dependent. Fluid storage. We can provide tanks for that. Whether your requirements require 1, 2, 3, or up to 10 or 12 tanks, again, is going to be operator and well site dependent. And then finally, the additional spare parts for chemical storage and redundant spare parts. Again, operator dependent if that's an absolute essential or necessary requirement. So how does it work? Dewatering during drilling is one of the features of the system. That means we're going to be processing and dewatering the fluid as it's actively being used. So while you're drilling, we're going to be keeping that water crystal clear to expedite and speed up your drilling operations. OBM active system management and cuttings processing. This is in the OBM section. We'll be targeting your LGS in the system at sub 4%. And then you can see the cuttings having been processed in the video. And you can see just how clean they are, how dry they are, and no visible evidence of any oil residue left on the cuttings. Water-based active system management, again, processing your active system while you're drilling, and we'll be targeting LGS to be between 4 and 6% at this time. End of hole or end of section stripping operations is where we break down the water-based mud into water and to solids. The solids discard, and the water is saved and returned to storage for future use. Barite recovery and active system processing in either water-based mud or oil-based muds. And we can also do cuttings processing if we're in oil-based muds with barite and active system processing simultaneously. So why pitless drilling technology? Oman's 2040 vision states, the Sultanate shall make unremitting efforts to ensure the natural resources are protected and used in a safe, sound manner, people are protected from harmful environmental impacts, and that the environment is effectively managed in a way that supports prosperity of the society. And for this, the vision's top priorities include concern for the environment, as well as an established culture with citizens and institutions alike. It also includes that environmental perspective is considered when making policies and decisions with respect to industrial planning and implementation. So that aligns completely with what pitless drilling delivers. The number one benefit of pitless is the elimination of the pits and to protect the environment. So why, and how are we going to do it? Why pitless? Well, pitless drilling will provide you with a technological, effective solution to drill faster, cleaner, safer, and greener. And how do we accomplish that? By this endless recycle, reduce, and reuse. So reduce, recycle, reuse. And by less cuttings being generated, less water being generated, recycling OBM, we're going to start targeting the environmental by the elimination of the waste pits and elimination of that 1,000-year legacy. We're going to be attacking costs, again, through the elimination of the pits, reduction in water consumption, less volumes. ROP efficiencies potentially, and obviously safety with the automation that's integral within our system, get rid of the excavations and the harmful pit vapors associated with those fluids. So now we're looking at the case studies, and we have a number of different ones. I'm not going to go through them all in detail, but I will emphasize that in every single case that's shown here, all the way from 2005 to 2021, the common denominator in every case is that 0 pits were required. The Oman case, of course, there were pits that were excavated, but they were not used when we could perform the trial. The waste pits were left unused. So quite a cross-section of wells over quite a range of time that shows Pitless does definitely work. It's a proven technology, and it's long overdue. So we have to ask ourselves, do we want to continue with the picture on the left with that environmental liability and safety issues ongoing, or do we want to move to the one on the right and reduce our water consumptions, 80% of it recovered for reuse, zero out our environmental legacy and liability, and improve our site safety by 100%. And that concludes our presentation. Thank you.